going to continue our discussion of definite integrals and antiderivatives and try to make a connection between all of those. So I'm going to start off with an example, and then I'll work one of the problems from the worksheet that I've given you. A little complex, that particular problem, so I'll work that for you, and then give you some guidance to help you be successful in today's worksheet. So let's start off with this example. I've got this function. F of x is defined like this: negative x plus 5, and I'm interested in what's going on that interval from 1 to 3. Now I'm given three or four different tests on the worksheet. So I'll work this problem like the worksheet problems are set up. So the first thing I'm supposed to do is find the definite integral of this function f of x. So that's going to be negative x plus 5 dx on this interval. So I'm interested in that definite integral from 1 to 3. And I'm asked to calculate the value of this, but to do it geometrically. So basically graph this function, then determine the value geometrically. So I'll do that. But I'm going to go ahead and graph this function and to get an idea what this looks like geometrically. Has a vertical intercept of 5, horizontal intercept of 5. This is the line connecting those two. And I need to break this into 5 pieces. All right, so 1, 2, 3, 4, 5. We'll pretend that that's perfect. I'm interested in what's going on between 1 and 3. So 1's up here. This is a value of 4. I can plug in the 1 in there. I get negative 1 plus 5 is 4. 3 is up here at a value of 2. Negative 3 plus 5 is 2. So I'm interested in this area here. Now I can break that into two different geometric shapes. I've got this triangle here and then this rectangle. Now this rectangle has width 2, height 2. So 2 times 2 is 4. So the area of this piece is 4. This triangle has base 2 units, height 2 units. 2 times 2 is 4, but it's a triangle, so I need to take half of that. So that gives me 2. So altogether, I see I've got 6. So this definite integral is equal to 6, and I found that value geometrically. The next task I'm given is to determine the integral of negative x plus 5 dx. So find the function that has this as its derivative. Okay, so this almost looks like the derivative of x squared. The derivative of x squared is 2x, but this is just a negative x. So let's see what that might be. I'm going to guess negative 1/2 x squared, and let's just double check it. If I take the derivative of this, I bring the 2 down in front. The 2 times the 1/2 makes it a 1, and then I've got the negative. So it's a negative 1. I drop the exponent by 1. I get negative 1x. Yeah, that's what I have. The function whose derivative is 5 is 5x. And then, of course, since there's infinitely many functions with this derivative, I add the plus c to capture the idea that there are infinitely many functions. So this new function we're going to call big F of x. It's the antiderivative of little f of x. So this big F of x function here. So the next thing I'm going to do, I'm going to evaluate big F of x at these endpoints of this interval. So big F of 3, I'll do that one first. That means I'm looking for negative 1/2 times 3 squared plus 5 times 3 plus the constant. So let's see, 3 squared is 9, half of 9 is 4.5. So I've got negative 4.5. 3 times 5 is 15. So 15 minus 4.5, that's going to give me 10.5. Now let me plus that constant, right? Let me now evaluate f of 1. I get, plug in the 1, negative 1/2 times 1 squared plus 5 times 1. It's 5 minus a half. This is 4.5 plus c. The final thing I'm asked to do is to try to make a connection or observe in all these problems that you're going to work. What is the relationship between these quantities and this value of the definite integral? So the task I'm to figure out is I've got this 10.5 plus c. I've got this 4.5 plus c. And I've got this value of 6, with this being, of course, my f of b, this being my f of a, and this being my definite integral from a to b of little f of x dx. And my task is to kind of look at these values and see if I can figure out a relationship between these values of big F, the antiderivative of little f. Is there a relationship I can figure out between these and this value of 6? So I'm not going to tell you what that relationship is. I want you to discover it yourself. But as you look through the various problems, the relationship will be the same for all of the problems. So as you work this through, observe for what you might see. And you might already see it, but I'm not going to tell you. All right. So this is the first problem. Now I'm going to work on a more complex problem. And this one is on the worksheet I've given you. And it's more complex because it involves what we call a piecewise function. So I'll go and work that one for you. Okay, we're going to go ahead and dive into problem number 4. I've got f of x equals negative the absolute value of x plus 3 on this interval from -1 to 2. So the first thing I'll do is I'll go ahead and graph this function. I know the absolute value of x is a v. The negative is going to flip that v upside down, and the 3 is going to slide that function up. So if I graph this function, it's going to be up here at 3. So there's 3, 2, and 1. It's going to be this inverted v. And it'll look something like this. So let's see. We go out here, call that 3 out there. Call this -3 back here. It's going to look like this. That inverted V. And I'm only interested in what's going on between -1. Let's call this -1 here. And 2. There's 1, there's 2. So I'm looking at this region in here. Now we can approach this geometrically a wide variety of ways. Let me go ahead and focus on this triangle here. This one up top. And then I will do this little triangle here. This little triangle here, I'll have this square here, and I've got this square there. Okay, so the width here is 2, the height's 2, so the area of this big square is 4. The width here is 1, the height is also 1, this is 1, width is 1, height's 1, so this is 1/2. Now this one, the base is 2 units long. The height is 1 unit, 2 times 1, and I'm going to take half of that. That gives me 1. So this definite integral from -1 to 2 of negative the absolute value of x plus 3 is the sum of these values. 4 plus 1 is 5, plus 1 is 6.5. So that is the value of this definite integral. Okay, so far so good, not too bad. The next thing is I need to figure out what function has this as its derivative. And that's where it gets a little bit complicated because we haven't dealt with the absolute value before. Well, the absolute value is formally defined like this. The absolute value is x if x is bigger than or equal to 0, or it's the opposite of x if x is less than 0. Let's make sure that works. So if I plug in, say, -3 into the absolute value function, I expect to get out +3. Well, -3 is +3. Yeah, so this is the formal definition here. So let me try to figure out then what would be the integral. I'm going to do this in steps. What would be the antiderivative of this function, the absolute value of x? Well, let's think about it. It's going to be a piecewise function. I need that if x is bigger than or equal to 0, I need the derivative to be x. So let me see, does 1/2 x squared work? If I take the 2 times the 1/2, that gives me 1. And I got the x by 1, that'll give me x. So yeah, that seems to work for this one if x is greater than or equal to 0. Now, what about this one? What function has the derivative of -x? Well, it's just going to be the opposite of this. So -1/2 x squared. Let me double check. I bring the 2 down in front. 2 times the half is 1. I've got the negative, so it's -1. Drop the x by 1. I get x. So yeah. So that matches. So here is my antiderivative for the absolute value of x. But I don't have the absolute value of x. I've got this other stuff going on. So what would be the antiderivative of negative absolute value of x dx? Well, it's going to be just the same, except for I'm going to multiply everything by a negative number. So it's just going to look like this. -1/2 x squared if x is greater than or equal to 0. And 1/2 x squared if x is less than 0. Okay, that wasn't too hard. Now, what function has the derivative of 3? Well, that's 3x. Derivative of 3x is 3. So I'm just going to add that on. So my integral of negative the absolute value of x plus 3 dx will be, again, this piecewise function, -1/2 x squared, just as before, plus the function whose derivative is 3, that's 3x. And then we have if x is greater than or equal to 0. Then finally 1/2 x squared plus 3x if x is less than 0. Okay, a lot of work we did there. This is my big F of x. Equals that function, of course, plus that constant. I probably should have just added the constant in here for both of these just to be consistent. All right, so a lot of work we just did to find the function whose antiderivative is, function whose derivative is this. So I'm going to go ahead and write that here. My big F of x function is equal to, it's this piecewise function. It's -1/2 x squared plus 3x plus a constant if x is greater than or equal to 0, and it's +1/2 x squared plus 3x plus the constant if x is less than 0. First thing I need to do is evaluate this function at 2. So I look here, let's see, 2 is greater than or equal to 0, so I'm going to use this part of the function. So it'll be -1/2 times 2 squared. Well, 2 squared is 4. So -1/2 of 4 is -2. So I have -2 from this. 2 going in there, 3 times 2 is 6. So 6 here minus the 2 there gives me a value of 4 plus that constant. Now I'm supposed to evaluate f of -1. Well, -1 meets this criteria down here. So I'm going to plug in that into this equation. So I get -1 squared is 1 times a half. So I've got a half here. 3 times -1 gives me -3 plus that half. So that would be -2.5. plus that constant. So where do we go from there? Well, my final step is I'm supposed to try to see if I can figure out how those are connected. So I've got the definite integral from -1 to 1 of negative absolute value of x plus 3 is equal to 6 dx is equal to 6.5. I've got that big F of 2 is equal to 4 plus constant. And I've got big F of -1 is equal to 2.5 plus that same constant. And again, I'm supposed to try to figure out the relationship. Oh, and that's a negative. Thank you. The relationship between these and this value here. So we're looking for a pattern across all of these problems to try to figure out that relationship. All right, hopefully that one made sense for you. With that, I turn you loose to work on the activities.